So, all right. So guys, now we will start to discuss something about the unguided part. Okay. So previously, the previous part, the question I show you just now is something to do with guided question. So what is guided question? Guided question means they prepare all the procedure for us. We follow all the procedure. That's all. Okay. But this year there is a rumors. So let me bring you back to the condition first. This year there is a rumors that it will be unguided. So let's look at the rumor for this year. The rumor for SPM 2023 is this. Okay, the rumor is that for chemistry, the question is unguided. So unguided means they didn't provide any procedure for us, and it makes perfect sense. I told you why. Because last year and the year before, the unguided is physics and bio. So of course, there is a very high chance that this year the unguided will happen on chemistry. Okay. So again, what is unguided? You go into the lab, they didn't tell you what to do. They just put a bunch of material and a bunch of apparatus on the table, and they let you to die yourself. Yeah, they let you to die yourself. Yeah, so you have to know what to do with those things. Understand? All right. So, and this year the rumors for the unguided question would be rate of reaction. Okay, so the rate of reaction, and it is actually temperature. So this is actually being discussed now. Okay, this is actually a very hot topic for now lah. Okay, so like what I say, don't only study the tips. You cannot only study one experiment. It is very dangerous. You need to study everything, and probably you slightly focus in this experiment. Understand? Study everything and slightly focus in this. Not only study this experiment. It's too risky. Is it okay? Come, let me tell you everything inside out. Everything you need to know for this experiment, just in case if this experiment really came out, how to score. Clear? I'll tell you everything inside out that you need to know for this experiment. So first of all, because it's unguided, you need to know what to do with this experiment. Okay, for rate of reaction, for temperature, actually there are two experiments you need to know. There are two experiments actually for the rate of reaction temperature. The first experiment is something in your textbook, which is this. You have a conical flask. Inside the conical flask, you have a liquid. This liquid is called sodium thiosulfate. Okay, this is called sodium thiosulfate. Then you put a piece of paper underneath. You put a piece of paper underneath here. You put a cross. And initially, you put your eyes on top here. When your eyes look at it, you can see the cross. Then you go to add acid. Okay? When you add acid, you will see that they will react. When sodium thiosulfate and acid reacted, they produce sulfur. Sulfur is a yellow color solid. When the yellow color solid is more and more, when the yellow color solid is getting thicker and thicker, sooner or later, your eyes cannot see this thing already. Get it? So we want to see how long it takes for the cross, for the pangkah to disappear. Understand? So everyone know this experiment, right? True or not? This is a very, very popular experiment. And maybe you don't know before this, but I guess after you heard about the tips, I think you guys probably go to read this experiment already. Is it okay? So this experiment, make sure you read about it. But for me personally, I don't think they will ask this experiment. I don't think they will ask this experiment, but you still prepare for it. Still read about it and understand what is happening. For me, I think the experiment not likely to be this. I think the experiment more likely to be tested is this. They will give you magnesium and they will give you hydrochloric acid. I think this experiment is more likely to be tested. Okay, first of all, what is happening here? When acid react with metal, we learned that you produce salt and hydrogen. So this experiment, because there is hydrogen, you should expect to see bubble. Understand? This experiment, you should expect to see gas bubbles. Okay, so before I teach you all the procedure, because remember, this is unguided. Unguided, you need to goreng your own procedure. You need to write your own procedure. Remember, don't memorize the procedure. No need. I don't want you to be a robot. I don't want you to memorize everything. No need. I want you all to understand what is happening. When you understand what is happening, when you can imagine what is happening, you can create your own procedure. Understand? Okay? So go follow me. I will teach step by step. First of all, I teach you theory. Then I teach you procedure. Then I will teach you the thing like hypothesis, operational definition, all the things. Here, we do step by step, okay? The purpose for us is what? We want to fully understand this experiment, rate of reaction, just in case if this question really asked in SPM, you know what you should do. Clear? All right? So come, let's start. So how to do this experiment? First and foremost, this magnesium, maybe they will give you magnesium ribbon. Maybe they will give you magnesium powder. I don't know. I don't know what they will give you. So if they give you magnesium powder, what you should do? You should decide how many gram you should use. Understand? Let's say when you do the experiment first time, let's say you use 5 grams of magnesium powder. When you repeat the experiment later on, use 5 grams also. You got it? Right? Then only fair, ma. Got it? Okay? Okay, if they never give you the powder, maybe they give you magnesium strip, or we call magnesium ribbon. You can call magnesium strip, or you can call it magnesium ribbon. So if they give you magnesium strip and ribbon, and they never tell you how much you should use, you can decide yourself. How to decide yourself? Take a knife and cut. Okay? How much to cut? Normally, how much to cut? About 3 to 5 cm. You like it? Okay? Okay, don't cut too long. Okay, sir, why we cannot cut 10 cm? Why? The reason very simple. If you use too many magnesium, the reaction will take forever to finish. Understand? If you use too many raw material, you have to wait a long time for the reaction to finish. You don't want that. Clear? Okay, why don't we put only 1 cm? If you only put so little magnesium, maybe when you throw in the acid, the reaction already finished. Too fast. Fast until you cannot record the time. Understand? No point. So that's why we go about 3 to 5 cm, just nice. Understand? So if they tell you how long you should use, follow. But if unguided, normally they don't tell. You decide yourself. Understand? 3 cm is okay, 4 cm is okay, 5 cm, no problem. Understand? Huh? Okay, let's say everyone, I cut 3 cm. After you cut 3 cm, what you should do? So guys, don't copy anything. I want you to listen and imagine what is going on. Okay, when we do any experiment, for metal, you always need to do one thing. Take this thing. This is called sandpaper. When you do any experiment for metal, you always need to take a sandpaper to scrub. Okay, to scrub or to rub on the metal. Do you know why? Do you know why? If you don't know, never mind. I will tell you now. The reason is this, everyone. Assuming this is magnesium, this is magnesium that I cut 3 cm. Magnesium is a metal. Ladies and gentlemen, metal is very reactive. So when metal exposed to the air, everyone, inside air got oxygen. When metal exposed to oxygen, they react. So when metal react with oxygen, you form metal oxide. That's why if this is magnesium, if magnesium ribbon exposed to the air for a long time, on top of the magnesium, Now you already have some magnesium oxide. Ladies and gentlemen, do we want magnesium oxide? No, I only want magnesium. Am I right? But there is magnesium oxide. Whoa, I don't want the magnesium oxide. What should I do? Remove it. Take the sandpaper, scrub, scrub, scrub. Understand? Scrub until when? Hey, don't over scrub, you know. Some people scrub for 20 minutes. Bro, you scrub for 20 minutes, no need to do experiment already. Okay? Some people say, sir, how long should I scrub? You scrub for about 30 seconds to 1 minute, enough already. Sir, if I scrub 1 minute, not clean enough, no worry. Even you scrub not clean enough, it won't affect the result one. Clear? So you scrub about 1 minute, you see, let's say, how to know the whole thing is quite clean already. Magnesium should be gray color, one. If there is magnesium oxide on top, maybe you see some white color or black color on top. You take the sandpaper, scrub, scrub, scrub. As long as the white color or the black color become lesser, maybe cannot completely remove it, maybe cannot completely clean it, never mind. As long as the black color and the white color on the magnesium become lesser, okay already, enough. So now the magnesium is clean. So ladies and gentlemen, do you know what happened now? Okay, after you cut the magnesium, always use the sandpaper to scrub. Why we want to do that? Remove the magnesium oxide, or we call remove the metal oxide on top there. Clear? Okay, because sometimes they may ask you, why the magnesium strip has to be cleaned with sandpaper if they ask the question. So how to answer? To remove magnesium oxide, or to remove surface of magnesium oxide. Understand? Settle. That's the first one. Now we have a clean magnesium already put aside. Now the next thing, what should we do? I want the reaction between magnesium with hydrochloric acid. So hydrochloric acid, normally you need to use a beaker. Take a beaker and put the acid inside. Okay, the concentration of the acid, you cannot control one. Normally they will give you the concentration of the acid. Let's say they give you the acid is 1 mole per dm cube, then you have to use it. If they give you the acid is 0.5, you have to use it. Understand? What you can do is this. You can decide how many volume. You can decide how many volume to use. Ladies and gentlemen, remember, like what I say early on, most probably this experiment is unguided. Unguided means what? They didn't give you all the procedures, so you have the freedom to decide how much you should use. Understand? Okay, so listen, guys. If you want to use any liquid, and they never tell you how much liquid you should use, you can use any value between 50 to 200. You like it? You can use 50 to 200. But don't use a weird number. Don't use 52 cm cube. Why you need the 2? Understand? No need, all right? So when you want to use, try to go in multiples of 10, 50, 60, 70, 80. Understand? Even better is what? Multiples of 50. Let's say 50, 100, 150, 200. Are you clear with that? If you ask my opinion, I will always take the lowest one, 50. Why? Okay, if you use a lot of hydrochloric acid, means you have a lot of raw material, everyone. When you have many raw material, what will happen? The reaction will take a long time to finish. Am I right? True or not? Just like magnesium, why we don't cut 10 cm? If you have too many magnesium, it takes forever to finish. Understand? You don't want. Remember, your paper 3 is 45 minutes. You need to use 45 minutes to do experiment and answer question. You don't want the experiment to take a long time to complete. Am I right, guys? True or not? So that's why use very little acid will do, about 50. Is it okay? So let's say I use 50 cm cube, 1 mole per dm cube, hydrochloric acid. Understand? Can I? Okay, now the next thing, how to do this experiment. Okay, this experiment, they want you to change different temperature. This one, I want everyone to listen. How to change temperature for the solution? We have to use Bunsen burner. So everyone, look at here, look at here. This is your Bunsen burner. So when you heat, guys, there is a skill, you know, there is a skill how you heat one. Okay, you don't need to heat the whole thing for a long, long time. No need one. Okay, if they never tell you what is the temperature, if they never tell you what is the temperature, you just do this. You just choose any three temperature enough. If they never tell you what is the temperature they wanted, you just choose three temperature. Let's say first one, 30. Second one, don't be too close. Don't choose 32. Too close already. Understand? Minimum, the gap is 10. Minimum, 40. If the gap is bigger, even better, 50. Understand? Get it? Okay, let's say I go for the gap of 10. 30, 40, and 50. Understand? You do three temperature, enough already. Clear? If the question never tell you what is the temperature to use, just go for three temperature will do. Is okay? 30, 40, 50, or you want 30, 50, 70 also can. You can choose yourself. The gap of temperature is 10 or 20, up to you. Clear? And don't give some very weird temperature, 45, 47. Don't do that. Okay? Try to go 30, 40, 50, all these things. Is it okay? All right, now, how to heat the solution, everyone? Bunsen burner. Okay, when you heat, what you need to do, everyone, listen, when you heat, what you should do. Number one, fire the fire. Don't make the flame too big. Because if the flame is too big, the heating process too fast. Very hard to control. Just make sure the flame is a small flame. Just make sure the flame is a small flame. Is it okay? Number two, when you heat, there's a skill. For example, you heat, let's say, you heat the whole thing, you use a thermometer to kacau. Okay? When you heat the whole thing, don't take the reading yet. Because when you do heating, you will see that the reading keep increasing one. So what you should do, everyone, you do like this. Let's say I go to heat the whole thing, maybe for, let's say, 30 seconds or 1 minute. Let's say I heat for 1 minute. After 1 minute, take off the fire. Okay? Take off the fire. Remove the Bunsen burner. After remove the Bunsen burner, take the glass rod, stir, kacau. Although now you are not heating already, stir, kacau. Kacau for how long? About 30 seconds to 1 minute, kacau. During the kacau process, when you stir the whole thing, you will see the temperature keep going up. So you wait until the temperature go up, go up, go up, become almost stop already, almost stopping already. Then only you record the temperature. Understand? All right. Sometimes cannot be very accurate one. Sometimes, for example, I want 30 degrees Celsius, but maybe I get 31. It's okay one. Sometimes I want 30, maybe I get 29. It's okay one. You got me? All right. So heat until that particular temperature. That's all. Okay? Can Okay, now let's start with this experiment. How to start with the experiment? After you heat the solution to 30 degrees Celsius, now you take your magnesium, just now that you clean already, the magnesium you clean already, now the magnesium throw inside. Understand? You throw the magnesium inside. When you throw the magnesium inside on the spot, go to start your stopwatch. Okay? Once you put the magnesium inside, stopwatch start. Okay, when you should stop the whole thing. Okay, two way. Number one, when you put in the magnesium, confirm you will see bubble. Why got bubble, everyone? Remember, I told you all just now. This experiment is magnesium and hydrochloric acid. When acid react with metal, we produce salt and hydrogen. So hydrogen is a gas. That's why you all will see bubbles. Understand? So guys, ladies and gentlemen, when should we stop the experiment? There are two ways for us to know this reaction has completed. First way, when you see the magnesium already dissolved. When all the magnesium disappear, you stop. Understand? Second method, which is even better, which is even more accurate. you open your eyes big and see the bubble. When you see no more bubble, you stop. Understand? When there is no more bubble, stop. Because when no more bubble means what? The reaction has completed. So far, so good. So you all know when to start, when to stop, right? When to start, when you throw in the magnesium in the acid. When to stop, when the magnesium fully dissolved, or when the bubble no more. So far, so good. Can I? Okay, so now you know this already. Okay, so when after you stop the stopwatch, you should do the recording. So all the result record in a table. Okay, all the result record in the table. I will show you the table in a short while. Is it okay? Lastly, you need to repeat this experiment with different temperature. So let's say I repeat again. I cut another 3 cm. I use the sandpaper, scrub. Am I right? Then I go to take the solution. How much? 50 cm cube, let's say. 50 cm cube of acid. Now I put a Bunsen burner and I heat. When you heat the solution, let's say heat until 40. When you heat until 40, you stop. Okay? So once you reach 40 degrees Celsius, now you want to start the experiment. How to start the experiment? Take the magnesium, throw inside. Yeah, take magnesium, throw inside. And then the experiment started. So when to stop? No more magnesium, no more bubble. Okay, can I repeat for 3 temperature? Always go for 3 temperature unless the question tell you what are the temperature. Let's say they tell you you should do 4 temperature, follow law. If let's say they say you should do 5 temperature, follow law. But if they never say 3 temperature is enough, 3 temperature is sufficient. If they didn't say anything. Are you with me, everyone? Can I? Good. So now that's it. Okay, now I already tell you all what you should do. Second thing, remember this is unguided. Unguided, you must write your own procedure. And I keep telling you guys, don't memorize the procedure. You can create, you can goreng your own answer. How to goreng the own answer? Remember all this picture I show you just now? If you can imagine what is going on, you can write all the procedure easily. Okay, how to write procedure? Let me show you an answer here. No need to copy, no need to memorize. Okay, so the procedure will look something like this. No need to memorize, no need to copy. Okay, okay, first and foremost, some student will ask, sir, I heard the procedure has to be written in active sentence. Ayat active. I heard the procedure should be written in the passive sentence, ayat passive. No such thing. You can write active or passive, up to you. Why? Bro, this is a science paper. This is not English paper. This is not Bahasa Melayu paper. They not really will check on your language. Are you okay that? They won't really check on your grammar, your grammatical mistakes. Ayat active or ayat passive. They don't care because this is not a language paper. So I don't care you write active or passive, doesn't matter. As long as you tell me what you should do, enough. Here, can I show you a sample answer? You don't need to be a robot. You don't need to be a photocopy machine to copy all my answer. No need one. Here, you write agak-agak, approximate the same thing will do. Okay, see, and all this step is exactly in the picture I show you just now. That's why I want you all to imagine the picture, isn't it? That's why just now I draw a lot of picture. Am I right, guys? Come, let's start. First one, cut 3 cm of magnesium. And it will be better if you tell them how you cut it by using a knife. Okay, by using a knife. Yeah. So next one, after you cut the magnesium ribbon, clean the magnesium ribbon by using sandpaper. Do you need to write this, everyone? Do you need to write clean the magnesium ribbon with sandpaper in order to remove the magnesium oxide? Do you need to write that? No need. Procedure, you just tell people what you do. You don't need to tell people why you do. Understand? You don't need to tell people, oh, why I do the sandpaper thing. No need one. Just tell people what you do. Okay? Can I? Next one. Okay, after you have the magnesium, okay, ready? Now let's try to prepare your solution. So your solution is your hydrochloric acid. So you need to measure the hydrochloric acid. Normally, how you measure, everyone? Measuring cylinder. Measuring cylinder. Use measuring cylinder to measure and pour 50 cm cube of 1 mole per dm cube hydrochloric acid in a beaker. Understand? This volume you can decide yourself. 50 to 200, you like it. Understand? This concentration depends on what they give you. Understand? You don't think the concentration must be 1.0. No, depends on what they give you. Because in the lab, they will have a label on the bottle to show you what is the concentration of the acid. Are you with me, everyone? Can So after you pour the acid into the beaker, what we need to do? Remember, this experiment, we want to study temperature. So you need to heat the hydrochloric acid to 30 degrees Celsius. This temperature, you decide yourself. Are you okay, everyone? And how you heat the solution, everyone? Bunsen burner. Okay, guys, how to know your answer, how to know your procedure is a good or a lousy one? A good procedure is this. They have no chance to shoot you. They have no chance to attack you. For example, if today you only write, heat the hydrochloric acid, I can shoot you. I will shoot you two things. Number one, I will shoot you. Heat by using what? Okay? You didn't tell me. Number two, I will shoot you. Heat to what temperature? Understand? So a good answer is that they have no chance to attack you. Okay? They cannot attack you one because your answer is so complete. Understand? So every time you write your procedure, you ask yourself, is this procedure good enough? Okay? Next one. After we have all these things, this one, everyone, put your eyes on here. Open your eyes, big, and look at here. Put a beaker on a white towel. Can you see I put star here? Okay, when I put star here means what? This step is optional. Guys, what do we mean by optional? Optional means you can choose to do or not to do. Okay? This white towel, why we put the beaker on white towel? Because of this, everyone see, when you have a beaker and when you put a white color towel, we learn in physics, white color reflect the light. Black color absorb the light. Am I right? Physics, huh? So when you have a white towel, what happened? When the light go in and reflected, this is your eyes. You can see the bubble more and more clearer. Okay? So the white towels only help you all to see the bubble more clearer. And this is optional. Optional means what? You can choose to put the white towel or not putting. Perfectly fine. Understand? So when you go into the lab, you go to see, do they give you white towel? If they never give you white towel, don't bother. Don't bother. If they give you white towel in the lab, you can choose whether you want to use it or you don't want to use it. Clear? All right, huh? So now that's it. So you see, put the white towel. This is optional. Okay, now let us start the experiment. How to start the experiment? Throw the magnesium into the beaker, and when the magnesium go into the beaker, start the stopwatch immediately. Understand? Once the magnesium go in, start the stopwatch. Okay, when should we stop the experiment, everyone? Stop the stopwatch as soon as no more gas bubble can be seen. True or not? If you don't want to write gas bubble, you can also write this. Stop the stopwatch once all the magnesium ribbon dissolve. Or stop the stopwatch once all the magnesium ribbon dissolve, or we can write disappear. Are you okay with that? Can everyone know? When there is no more magnesium, when there is no more bubble, means experiment finish. Stop. Okay? So once you stop, don't forget you should record your reading. Record what? Time taken. Am I right? Time, record the time where? In a table. Understand? Record your result in a table. Lastly, don't forget you need to repeat all your steps. Okay? You need to repeat the whole experiment by using different temperature. And guys, temperature for what? Hydrochloric acid. So not when you heat the solution, you heat the hydrochloric acid. Because if you only write different temperature, I can shoot you. Temperature of what? So not. Don't let people shoot you. So your procedure has to be as detailed as possible. So far, so good. So guys, can you see the procedure looks long, looks horrible, but it's not hard. Am I right? That's why I don't want you to memorize all these words. I want you to imagine what is going on. Am I right? When you can imagine what is going on, you can create this answer yourself. Can? All right? One important thing to remind you all is this. For any solution, you must mention the volume and concentration. Understand? You need to mention the volume and concentration. Okay? That's it. So now I already show you what you should do in the experiment and what is the procedure. Okay, now I will talk about the result. Okay, I will use the next 15 to 20 minutes talk about the result. Okay, so the result that you will get might look like this. Okay, the result you might get might look like this. So first of all, the result you can put in a table. So the first part of the table is temperature. So temperature is degree Celsius. Okay, so let's say they never tell us the temperature. You can put how many? 3 temperature. Let's say 30, 40, 50. Understand? When you prepare your table, make sure you write the full name, temperature. Don't write TEMT, short form. Don't write it. Don't only put a symbol, T. Don't do that. Write the full name, temperature. And please, please, please put the unit. Are you okay, everyone? Can I? Okay, temperature. Okay, guys, allow me to ask you all a simple question. This temperature, do I need to put 1 decimal point here? Yes or no? Yes or no? The answer, no. Why no need? Sir, just now you say need to put decimal point, now you say no need. True or not? Why? Listen carefully, guys. When should we put decimal point? I told you, 99% of the time we put 1 decimal point, right? True or not? Burette and ruler, we put 2 decimal point. Why in this case, you don't need to put the decimal point? Reason, very simple. You only put decimal point when you want to measure the result. When you want to measure the result. Guys, in this case, is the temperature the result of the experiment? No, temperature is the manipulated variable. True or not? In this experiment, I purposely change different temperature to study the rate of reaction. True or not? I purposely change different temperature in order to study the rate of reaction. So since the temperature is my manipulated variable, it is not the result I want. So when it is not the result I want, we don't put any decimal point. Understand or not? You only put decimal point whenever you are measuring a result. This is not a result. Temperature is not the result we wanted. All good? So no need. Second one. What is the result we want in this experiment? Remember just now, at different temperature, I throw the magnesium, I see bubble, 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 I stop. Okay? So the result I want from this experiment is what? Time. If you only write time, congratulations, 0, no mark. Time for what? Time taken. Time taken for what? Time taken for you to bathe. Time taken for you to take breakfast. No, right? Time taken to complete the reaction. Time taken to complete the reaction. If you don't want to write time taken to complete reaction, you also can say time taken for magnesium ribbon to dissolve. Time taken for magnesium to disappear. Or you can write time taken for gas bubble to disappear. Or time taken for the gas bubble to stop producing. Understand? You must tell them what is the time taken. Time taken for what? True or not? Okay? I keep on saying, don't let me shoot you. Okay? If you say time taken, I will shoot you for sure. Time taken for what? Understand? Okay, guys, what is the unit for time, everyone? Seconds. Okay? Okay, guys, let's say, if I get the result, 55 seconds. Okay, for the time, do we need to put decimal point? Yes or no? Yes, because the time is the result we wanted, true or not? The time is the final result we wanted. So all the result that we measure must have decimal point. How many decimal point? 1. So 55.0. Understand? Let's say 45.0. Let's say 35.0. This value don't copy. This value you have to do the experiment yourself. Understand? Okay. Normally they will ask us to do one more thing. Normally, they will ask us to do one more thing. This is called 1 over time. Okay, why we need to do 1 over time? Anything divided by time, you will get speed. Okay, this experiment is the rate of reaction. What is rate? Speed. You want to know the reaction fast or slow. So you want to know reaction fast or slow, you must divide by time. Understand? So you take 1 divided by time. So for example, you take this 1 divided by 55. You calculate 1 divided by 45. You calculate. Is it okay? So when you do calculation, how many decimal point you should put here? Listen carefully. Listen carefully. When you do your calculation, this is calculation. When you do your calculation, how many decimal point you should put? You shouldn't focus on decimal. You should focus on something you learn in mathematics, which is called significant figure. Everyone knows significant figure in mathematics? When you do calculation, keep the answer in 2SF, 2 significant figure. Example, if you get the answer 0.01767111428. So how to simplify in 2 significant figure? 0.018. Understand? Get it? 2 significant figure. For example, this one you calculate 0.021. For example, 0.024. For example, is it okay? So when you calculate something, 2 significant figure, when you record a result, 1 decimal point. Get it? So you must know when to use decimal point, when to use significant figure. All good? So now after you've gotten this table, normally they will ask you to plot a graph. Normally, they will ask you to plot a graph. There are 2 possible graphs they might ask you to plot, but they won't ask you to plot 2 graphs. They only ask you to plot one of them. The first graph is this. Temperature versus time. So this is temperature and this is the time. Yeah. So temperature is degrees Celsius, time is second. So if you plot the graph, it will look like this. No need to memorize. You should get a curve. Second one, the more important graph which I think they will ask is this. Temperature versus 1 over time. No worry, the question will clearly tell you what is the graph to plot. Understand? Temperature, the unit, degrees Celsius. Okay, 1 over time. What is the unit, everyone? 1 over time. Time is second. 1 divided by second. Second minus 1. Is it okay? So this is second minus 1. So this one, okay, when you plot the graph, I would like to tell you some story here. When you plot the graph, always make sure that you use at least 50% of the graph paper. You know that? You should use the graph paper as much as possible. You cannot say the graph paper so big, but your graph so small and cute. Cannot. I don't want a cute graph. I want you use the graph at least 50% the graph paper. Okay? The graph paper, you can use the vertical, straight one, or you can use horizontal. Up to you. So when you do the graph, guys, listen. Not necessary the skill must start from 0. Not necessary one. Not necessary starting from 0 1. Example, you see, in this case, my temperature start from 30. It is okay for your temperature not starting from 0 1. You can start from 30, then go for 40, then go for 50. Is it okay? No problem one. No people say that temperature must start from 0. No people say that. Okay? Same thing. Your 1 over time. 1 over time not necessarily starting from 0 1. No. Your 1 over time, let's say, my 1 over time starting from 0.018. So you can do this. Here is 0.018. No problem one. Then followed by, okay, let's say 0.020, 0.022, for example, something like that. Is it okay? So when you plot the graph, it will look like this. At 30 degrees Celsius, your 1 over time is 0.018, like this. You plot all the line, for example, the final answer supposed to be a straight line. Understand? So if you plot temperature versus 1 over time, you will get a straight line. If you plot temperature versus time only, you will get a curve. Is it okay? So make sure you know how to plot the graph. Don't memorize the answer. Yeah? So depends on you. Okay? Can So now we already get all these things. Okay, now the next thing, which is the last thing, is we need to discuss the question. So how they can ask us question over here? Again, what question they can ask? Nothing different from this. Observation, inference, variable, hypothesis, operational definition. This is what they can ask. So I will discuss all these five very quickly with you. Is it okay? First of all, what is the expected observation? So what you expect to see here? You can expect to see a few things. Number one, you might see colorless gas bubble. You might see colorless gas bubble. Okay, if you don't want to write colorless gas bubble, you also can write magnesium ribbon dissolve. So not, okay, when you do this experiment, you expect the magnesium will disappear, or you can expect the colorless gas bubble is produced. So far so good? These two answer, don't write both, choose one. Clear? All right? And after that, inference. Everyone, recall back what we learned. What is inference? Explanation of your observation. You need to explain your observation. So if you write colorless gas bubble, so you must ask yourself, why? Why I see colorless gas bubble? So we know this reaction is acid plus magnesium metal. Acid plus metal produce salt and hydrogen. Who is the gas bubble? Hydrogen. So if you want to go for inference, you must tell people why I saw colorless gas bubble. Because hydrogen gas is produced. Understand? Why got gas bubble? Because hydrogen gas is produced. See that? Okay. If you write magnesium ribbon dissolve, if just now the observation you write magnesium ribbon dissolve, then what should be your inference? So you must explain why. Why the magnesium ribbon dissolve? Magnesium ribbon dissolve because magnesium react with hydrochloric acid. True or not? When the magnesium react with hydrochloric acid, no more magnesium. That's why the magnesium ribbon dissolve. Understand? So if the question asks, if let's say you write observation, you write magnesium ribbon dissolve. So what would be your inference? Magnesium react with hydrochloric acid. That's all. Clear? Simple. So now we are done with observation and inference. So far so good, everyone? Can. The next one, variable. So remember, we have three variable, MV, RV, CV. Manipulated variable, responding variable, and constant variable. Okay, guys, listen carefully. What is manipulated variable? When we do this experiment, we want to study different temperature and rate of reaction. Am I right? So what we change, everyone? Temperature, we go to change the temperature, and then we want to see the reaction is fast or slow. Am I right? So when you go to write variable, don't only write the word temperature. Not good. Because again, if you write temperature, I will shoot you again. I will ask you, temperature of who? Clear? So you must tell me you are changing the temperature of hydrochloric acid. When you write the answer, cannot do the short form like this. Cannot write TEMP, must write temperature. Cannot put HCl, must write the full name, hydrochloric acid. Understand? So the manipulated variable is the temperature of the hydrochloric acid. What is the responding variable? So when we use different temperature of hydrochloric acid, we want to see what is the rate of reaction. Because remember, why we do this experiment? To find the rate of reaction. The purpose of the experiment is always the responding variable. Understand? The reason why we do the experiment is always the responding variable. Is it okay? That is what you need to know. Okay? So if you don't want to write rate of reaction, also no problem. Just now when we use different temperature for the hydrochloric acid, what is the final result? Let's say at 30 degrees Celsius, I start the stopwatch and I see how long it takes for the bubble to disappear. When I use 40 degrees Celsius, I will check how long it takes for the bubble to disappear. True or not? Different temperature, you will see different time for the bubble to disappear. So the time taken for the bubble to disappear is actually the result I wanted. So all the result I wanted, all the purpose of the experiment can be my responding variable. Understand? So the responding variable here got two answers. You can write rate of reaction. You also can write time taken to complete the reaction. If you don't want to write time taken to complete reaction, you also can say time taken for magnesium ribbon to disappear, time taken for the gas bubble to disappear. Understand? Okay, last one, constant variable. So guys, how to know what is constant variable? You must ask yourself, anything you can change, anything that you change, it will affect the result one. Anything when we changes, it will affect the result one. So in this case, what can affect the result? The first one, the solution. So this solution is hydrochloric acid. If you change the hydrochloric acid to other solution, it will affect the result. Am I right? If I change hydrochloric acid to sulfuric acid, the result will be different. If I change hydrochloric acid to something else, it will be different. So the solution is important, right? So every time when you want to fix a solution, I mentioned before, when you want to fix a solution, what to fix, everyone? Volume and concentration. So fix the volume and concentration of hydrochloric acid. Okay, what are the other factor? What is another factor which can affect the result? Ribbon, magnesium ribbon. You cannot say this. First experiment, I used 5 cm. Second experiment, I used 10 cm. Cannot. Here, cannot. Okay, when you use different amount of magnesium, the final result will be very different. All good? That's all. Okay, so these two constant variable, you don't need to write both. You just choose one to write. So far, so good? So this is your manipulated responding and constant variable. Okay, lastly, two more things to go. Hypothesis. What is hypothesis, everyone? Hypothesis is the relationship between manipulated and responding variable. My manipulated variable is the temperature of hydrochloric acid. My responding variable is the rate of reaction or time taken. Remember, when you want to give a good relationship for the hypothesis, always use some powerful word, higher, lower, bigger, smaller, all these powerful words. So how we can relate temperature and also rate of reaction? You can write this. The higher the temperature, the higher the rate of reaction. Okay, how to make the answer even better? Can you specify this temperature refer to who? Temperature of hydrochloric acid. Understand? The higher the temperature of hydrochloric acid, the higher the rate of reaction. Understand? Okay, if you don't want to write rate of reaction, also can. Because just now I told you, your responding variable also can be time taken, right? Or not? So you also can say, the higher the temperature of hydrochloric acid, the shorter the time taken to complete the reaction. So far, so good? So I think it's quite easy, right? This hypothesis. Just give me a good relationship between MV and RV. Lastly, last part, operational definition. How to give a good operational definition for the question here. Remember, we learned what is operational definition. Operational definition tell people what you do and tell people what you get. Okay, what you do and what you get. So the question might ask you all, what is operational definition for rate of reaction? The question might asking, what is the operational definition for rate of reaction? So how to do this? How to find operational definition for rate of reaction? So ask yourself, what I need to do to get the rate of reaction? And what is the result? What is the observation I should get? Get it? So guys, what I should do. Look at the picture. Everyone recall back what we do today. What we do today. We put magnesium into hydrochloric acid. Am I right? Okay, we put magnesium into hydrochloric acid. What I get gas bubble. But guys, here is the problem. If I only see the gas bubble, can the gas bubble tell me the rate of reaction? No. The gas bubble only tell me there is a reaction, but it cannot tell me the reaction fast or slow. So how to know the reaction fast or slow? You not only need to see the bubble, you must see the time taken. You must see the bubble lasts for how long. For example, the bubble appear for 20 seconds. The bubble appear for 50 seconds. Understand? You need to go to see how long the bubble is there. If you don't want to see bubble, no problem. You go to see the magnesium. How long the magnesium disappear. It's okay? So how to get a good operational definition? you can get an answer like this. You see, yeah? What I do, magnesium added to hydrochloric acid. Am I right? This is what I do, right? What I get, time taken for the gas bubble to disappear. Am I right or not? I go to put magnesium inside hydrochloric acid. I will see I will see how long it takes for the gas bubble to disappear. And this is my rate of reaction. Understand? See that? So the answer can be like this. When magnesium is added into hydrochloric acid, the time taken for the gas bubble to disappear is the rate of reaction. See that? So this is what I do. This is what I get. You also can change the structure. For me, I prefer to change the structure. This is what you do. This is what you get. For me personally, I love to write this. I love to write what I get first, then only what I do. Trust me, the sentence will look more beautiful one. You see, yeah? The sentence will look more beautiful. You see, yeah? You write what you get first. Time taken. Okay. So the time taken for the gas bubble to disappear. This is what I get. Okay. What I do. Okay. When magnesium is added to hydrochloric acid. You see that, everyone? The blue color is what I do. The black color is what I get. See that? So you can change the sequence. You can put what you do in front and what you get at the back. But for me personally, I prefer to put what I get in front and what I do at the back. Understand? That is only my personal preference. You not necessarily follow me. But if you can compare, if you look at the answer, the sequence, the sentence, if you put what you get in front, the whole sentence actually look nicer. Actually, the whole sentence actually look nicer now. You got me? So remember, operational definition, just go to tell people what you do and what you get. All right? So with that being said, we are all done with the paper 3. Is it okay? So paper 3, I already show you how to do unguided and how to do guided and how to do unguided. So far so good. It's not very, very hard. Okay. Most importantly, understand the concept. Yeah. All right. So I hope you really learn something from here. What if this experiment really, really come out? Now I hope you can do something about it. Yeah.